Hello everyone, this is how you solve a rational equation. We may have done this in class, right? And I want you to take a look, kind of as a refresher, on how to do it. If you missed the solution while we were in class, this is how you would tackle it, right? So a couple of things we have to do to solve rational equations, right? We want to get rid of the denominators, and to do that, we have to multiply each term here. This term right here, this term right here, and this term right here by the LCD to get rid of the denominators, or that will make our life complicated. To do that, we have to find the LCD, right? To multiply everything by the LCD, we have to find the LCD, right? And a lot of times what these problems, right, we have to factor, right? We have to factor some term, right? We can't factor this to find the LCD, right? To make sure we're not doing any extra work, right? So we have x here, 4 over x. We have x minus 2, 5 over x minus 2, all right? So this is the only one out here, right? X squared minus 2x. So let's factor this, right? X squared minus 2x, right? X squared minus 2x equals, right? X, right? They both share an x, so I'm taking out an x from both, right? X times x minus 2, right? X times x is x squared. X times minus 2 is minus 2x, right? So this is this factor, right? And what do you know? A lot of these questions, right? When you factor, right, something that's factorable, you'll find the LCD, right? This is x times x minus 2, and this is x, and this is x minus 2, right? So we're just multiplying this factor by this factor by this factor, and that gives us the LCD, right? So our LCD is x minus 2. All right, another thing we can do, right, once we find the LCD, we have to find what x cannot be, right? All right, x cannot be, right? So if we find this as a solution, right, it's extraneous. That means we can't use it. It'll make our equation invalid, which probably means we're dividing by 0, which, is not okay for our math class. All right, so let's see, right? What is this factor? What is the 0 for this? What is the 0 for this, right? The 0 for just x by itself is 0, right? Whatever I put into x to make this factor 0, 0, 0, right? What about here? What is the 0 for x minus 2, right? So how can I find that? What can I put into this x to make x minus 2 a 0, right? So the answer there is 2, right? 2 minus 2 is 0, right? So x can be 0 or 2. If you find those, we have to reject it. All right. Now we're going to multiply everything by the LCD, all the terms, to get rid of our denominator, right? So x minus 2 times 10 over x squared minus 2x plus x times x minus 2 times 4 over x equals x times x minus 2 times 5 over x minus 2. All right, so there's a lot of stuff we can cancel out here, right? So I'm multiplying everything by the LCD, right? X times x minus 2 is the same as x squared minus 2x, so this whole thing cancels out here, right? Okay, now, right, x and x cancel out here, and x minus 2, and this cancels out here. All right, so let's keep going, right? So over here, I just have a 10 left over, 10, and then I have plus x minus 2 times 4, all right, 4, equals x times 5, right? X times 5 from over here. All right, so I have 10 plus 4 times x is 4x. 4 times negative 2 is negative 8. All right, all I did was distribute here. All right, equals 5x. All right, so let's combine like terms, right? Let's combine like terms. So I'm going to have 4x, right? 2 plus 4x. 10 plus negative 8 is, or 10 minus 8 is 2, right? Equals 5x. Solving for x now, this is very simple. Subtract 4x from both sides, and I get 2 equals x, right? This cancels out. 5x minus 4x equals just x. 2 equals x. All right, so I can say 2 will work, right? I found the solution, right? But remember from back at our first or second step here, right? We said x cannot be 2. And I get 2 equals x. That's my solution. That means I have to reject 2. This does not work. So we write here, no solution, right? No solution, right? No solution, right? And that is our answer here, right? We reject this. All right. Let's take a look at another problem. All right, let's take a look at another problem. All right, so I have x plus 2 over x plus x over 3 equals 2x squared plus 6 over 3x. Okay, again, what do we want to do? We want the LCDs. We want to find the extraneous solutions right off the bat, right? So right here, our LCD is, what is our LCD, right? Okay, we could factor this kind of, not really, right? I have 3 here, I have x here, and I have 3x here, right? So this is 3 times x, right? So our LCD is just 3x, right? This one is very straightforward and simple, right? I'm just multiplying 3 times x. And there's a 3 times x here, so nothing to be done. What's the 0 here, right? What can I put into, what can x not be here? What is the extraneous solution, right? Over here, I have an x. Over here, and I have an x. So I have to look at what I can put into these x to make it 0, right? That's simple, right? I just insert x as 0, right? That's it, right? There's nothing else here, right? And now we multiply everything by the LCD. So let's do that, right? Let's multiply all the terms by the LCD. So I'm going to have 3x times x plus 2 over x plus 3x times x over 3 equals 3x times 2x squared plus 6 over 3x. All right. As you can see, there's a lot of stuff to cancel here. So let's do that. Let's cancel this x here, this x here. Let's cancel this 3 here, this 3 here. And let's cancel the 3x here and 3x here. And let's bring down what we have remaining. All right. So all I have left here is 3. I'm just going to rewrite it. X plus 2, right? These x's are gone, so all I have this. Plus all I have left over is x times this x here equals 2x squared plus 6. All right, so I'm going to get 3x plus 6, x times x is x squared, equals 2x squared plus 6. All right. Now, this looks like a quadratic to me. There's a power 2 here, so I'm going to bring everything to one side so I can maybe use the quadratic formula, or I can factor to solve, right? So what I'm going to do here, I'm going to bring everything over to this side, to this right side here, because 2x squared is bigger than x squared, right? So I'm going to bring everything to this side. So I'm going to subtract 3x, subtract 6, and subtract x squared from both sides of the equation, right? So I'm subtracting x squared, I'm subtracting 6, and I'm subtracting 3x from both sides, right? Just like I did here. All right, so obviously this all cancels out, which is exactly what I want. All right, so I get 0 equals 2x squared minus x squared, right? So I only have one x squared left, right? So I just have x squared left. 6 minus 6, well, those two cancel out, right? 6 and minus 6, they cancel out. And I have minus 3x, right? I bring this minus 3x over. That's it, right? All right, well, this to me looks easily factorable, right? This term and this term, the x squared and the minus 3x, both share an x. So I'm just going to factor it, right? So 0 equals x minus 3. All right, so my zeros of this, my zeros on my factors are my solution, right? So just for clarification, this is x by itself, so I could kind of represent this as x minus 0 write this right here, and x minus 3 is just x minus 3, right? X minus 0 is just x, right? So I can represent as that, right? So the 0 for this is, so x is going to be, right, 0, and x minus 3, the 0 for this is, what will make this factor 0? So x minus 3 equals 0, and I'm solving for x here. I add 3 to both sides, so x equals 3. So my solutions are x and 3. But hold up 1 second here, right? Again, this is why these steps are so important. Let's go back to the beginning. What can x not be, right? What can x not be? X cannot be 0, so we reject 0. That is an extraneous solution, right? So our answer here actually is x is only 3, right? That is my only solution. That is my only solution. All right, let's take a look at this problem, right? Just like the previous problems, we have to find the LCD and we have to find what x cannot be the extraneous solutions, right? So let's take a look. 2x minus 1, there's not much to do here, right? 1 over 2x minus 1 for the denominator here. I can't factor 2x minus 1 anymore, so we leave it as is. Let's take a look at 8x minus 4. This problem right here, right? This part of the equation right here. So 8x minus 4. Let's try to factor 8x minus 4. Well, 8 and 4 are divisible by what, right? There's no x on this term, so there's nothing to do here with the 4, negative 4. So 8 and negative 4, what do they share? They both share 4, right? I could pull a 4 out, right? How many times does 4 go into 8? 2. And how many times does 4 go into negative 4? Negative 1, right? So this is what it's fully factored, right? Now, surprisingly, right? Let's take a look. Let's rewrite this. 1 over 2x minus 1 equals 4 over 4 2x minus 1. All right. So there's a couple of things we might notice, but I want to do the problem fully, right? All right. So let's take a look, right? So this is 4 times 2x minus 1. So what is our LCD? If you could guess, right, if I put a parenthesis here, what is this term missing that this term has, right? This is missing a 4 in front of it, right? So we could say our LCD equals 4 times 2x minus 1, all right? And what can x not be? What are extraneous solutions for x, right? So let's take a look. Let's solve, right? Let's solve right here, right? Let's set 2x minus 1 to 0. We're solving for x, right? That's how we find the zeros of the factor, right? So 2x minus, I'm going to add 1 to both sides. So 2x equals 1, x equals 1/2, right? So x cannot be 1/2. All right, let's keep that in mind. If that shows up as a solution, we have to reject it. All right, we have to reject it. All right. So let's keep going, right? This has all the factors. I don't have to do anything. All I have to do is multiply everything now by the LCD, right? So I'm going to do 4 2x minus 1 times 1 over 2x minus 1 equals 4 over 4 times 2x minus 1 times 4 2x minus 1, right? All right, so as you can see here, this cancels out over here, and over here, this whole thing cancels out. This whole thing cancels out. So all I'm left with is 4 times 1 equals 4. So yeah, of course 4 equals 4, right? Of course 4 equals 4. So when you see something like this, if you see two numbers equal to each other, when you solve this, right? If you see 4 equals 4, if you see something like, say, another problem where you see something like x equals x, all right? If you see 0 equals 0, all right? So what does that mean when you get 4 equals to 4, right? That means when you have the same number on both sides equal each other, right? That means there's infinitely many solutions, right? That means all numbers will work, right? So for this problem, there's infinitely many solutions, right? Infinitely many solutions, all right? Infinitely many solutions, except for just one, right? There's one solution that cannot be used, which is this one. This is the only extraneous solution, x when x is 1/2. Infinitely many solutions except when x equals 1/2, right? Right? I can put in any number here, it'll work into x, right? More proper way, mathematical way, maybe you might see that is like this is all real numbers, right? All real numbers, and x cannot be 1/2, right? So again, another way to show it, you write this r, all real numbers, right? Minus 1/2, right? 1/2, right? I would just stick with this one, right? If you're feeling comfortable writing it this way, but this one works perfectly well, right? If you get it on the Regents or an exam, right? So this works, all right? Now, I want you to take a look at this example right here, over here. If you work it out, you'll get that there's, so why don't you pause the video, be like, well, hold up, right? Let me work this out. Let me find the LCD. Let me find what x can't be, right? And let me solve it myself, right? Okay, the solution for this one is no real solutions, right? No real solutions, no complex solutions either, in fact, right? So this one's just no solutions, right? No solutions whatsoever for this one. And let's take a look at another one, right? So again, you can pause the video and try it yourself. Let's take a look at 2 over a plus 4 plus 2a minus 1, or a squared plus 2a minus 8 equals 1 over a minus 2. All right. Pause the video. Find the LCD, right? Find the LCD. Find what x can't be, right? Try to solve it, right? Come back for the solution, right? Come back for the solution. Well, okay, if you're back and you tried it, the solution here is that sorry, there's an a here. A cannot be, sorry, getting ahead of myself. The solution here is a equals 3, right? That's the solution. A equals 3. All right, so that is the solution to the problem. All right, have a good day.